Hello, welcome to the last but one session, I'd call it. After this session, there will be the final words and the end keynote. That will be in A1. If you don't feel like moving away, you can stay here. This will be the overflow room, be the video feed from A1, so it's up to you. Either you go directly to A1 or you stay here. It's up to you. With that said, please welcome Rustam Mehmandarov.
Thank you very much. All right, let's talk about nightmares. Developer nightmares, what does it actually mean? And what is Dora? Anybody knows Dora? Not the cartoon Dora, but the other Dora? Oh, nice, good. Well, we'll see if that's... So if you try to Google Dora, you'll find a lot of things. So you need to actually Google for the right one. But we'll talk about that. But why are we talking about nightmares? And what kind of nightmares are we talking about? So this is a kind of a text adventure game style, working with legacy software kind of tweet. It's a really old tweet, but it's amazing, right? You're in a legacy code base. I've been there a lot of times myself. You try to understand how it works. You try to run tests. There are no tests, or they're not really well written. They're like disabled most of the times, what you'll see. You try to read spec. Well, spec is not there or not updated. Okay, fine. Okay, I can do that. You write a fix, and then, well, everything fails. And you take down the production. Anyone? Okay, a few brave hands, and that's nice. Yeah, welcome to the club. And the problem is that convincing your project manager or whoever is paying for you to do the job is really hard to actually make them spend money or time or both on doing all those things that, you know, make that nightmare go away. It's really hard because when they have to choose between new features and all that, what do they choose? New features, often, very often. So this is also kind of a bit old tweet now. It's getting old, but it's still, you know, it ages kind of well. What I will be talking about is kind of my experiences. I work and live in Norway, in Oslo, and I've been working a lot on big systems. I've been working as a consultant for, well, almost 20 years now. I've been working a lot of systems that has at least 350,000 lines of code, up to 500,000 lines of code. It's big systems, big Java systems, now quite legacy systems as well. And I've been doing reviews of systems like this as well that not even we have written, but somebody else. So I try to summarize those things and try to kind of create a bit system in the madness. And I try to see what makes a system bad, or like a nightmare or a paradise, right? The opposite of nightmare, I guess it's a paradise. Nice, fuzzy, warm place. And this is kind of the main parts that you will see. We'll talk a bit about each of them, and we'll try to connect that to to research made by people behind the Dora research and all that in a second as well. But to show you the main idea as well, you always have to do something with the code. You always have to do something with the tools that will help you to deploy and do something like that. And there is some part that is like documentation and all that. When it comes to code, you have tools to write code. You have third-party libraries. You have architecture and kind of obvious things, right? You would think, like, you would look at these things like, yeah, of course, we do that. I've done different versions of this talk in many places, many countries, over quite some time. And always I will get people coming down to me and say, look, we do understand all that, but we need help to convince our managers. How do you do that? And all these kind of things. And sometimes people would be like, oh, I never thought that would be a problem, and stuff like that as well. But, you know, speaking of nightmares, everything is relative. So I want to do a little quick recap. This is a 15-minute talk, but we'll still do a little like history. Who's been developer in like 90s, late 90s maybe? Okay, perfect. Okay, so you all get to correct me if I'm wrong, but, you know, there is a little, actually that's 80s reference, but I don't know if you see that, but there is a little bit thing missing there, but, you know, you get the point. Anyway, yeah, you know, people are laughing already. Yeah, we didn't do Agile. We were doing beautiful waterfalls. We were doing like, you know, waterfall development. That's one thing. The other thing was that we wouldn't have IDEs. I mean, I started writing my first Java code in Emacs. I mean, we're not doing Emacs Vim thing here, but you get the point, right? Kind of scary. We did versioning with this, not this thing that you actually is called the same name now, but the old thing. That was scary. The other thing was, it wasn't that scary, but it was kind of tedious. So yeah. Ooh, that was fun. I actually was doing that already even quite late in 2000s. Compile and build. Class paths and byte files. Anyone? Spaghetti? Go-tos? Yes. And Java from command line when you build that. Yes, there you go. Scary. Issue tracking, that's my personal favorite. We did that. How did you do that? Well, we put everything on MS Access. Single database, user database. How we made it multi-user? No, you put that on a shared network drive because file does not get corrupted when several people edit it, right? Yeah. So we did that. Now everything, all that is gone. So now it's rainbows and unicorns, right? It's all amazing and it's all fantastic and everything just works, right? Nervous laughter. Yes, exactly. Well, let's go and talk about those things. And I want to talk about those things that are being packaged to you very often as continuous something. I mean, a lot of those things that I'll be mentioning, you've heard in a packaging of continuous something, right? And it's like continuous integration, deployment, delivery, all those things. And, well, it's rainbows and unicorns again, right? It's being sold to you like that. It's being sold to you as dev ops, dev insert any 3-4 letter abbreviation thing ops, and cloud native and cloud and all this kind of things. I mean, again, it's a lot of common sense, but, all of them are being sold to you as one big rocket ship that will take you to the moon or Mars, wherever you want to go. And, if you do all those, it will be amazing. But you don't really have to do that. You can actually do these things piece by piece. I want to show you this wall of text as well. It's a good idea to do it in a 15-minute talk. But to make it a bit easier, I did this and I did this. So now we actually have a cloud native definition, CNCF definition of what cloud native actually is. And then you see all those words that we'll be kind of touching upon. So that's cloud native, common sense, but a lot of things that we need to do, and we sometimes don't do that. Do we loosely coupled resilience, focus on resilience, manageability, if you can say that, observability, and all those kind of things. That's the Dora part comes in as well. So they did a research. They did a lot of people at Google did a lot of research on how developers thrive, how organizations thrive, and how do you develop good software and stuff like that. And they came up with this kind of flow chart. The most what you see on the left side is a lot of common sense things that you will already have seen in the definition of cloud native. That I will probably mention some of them in a second, as much as I have time, but. The important thing here in the middle is the green box that's called performance. I'm going to zoom that in for you. So that's the right URL to Dora, by the way. That's what they talk about. They talk about to create, and actually, let's go back for a second. So all those things that you see on the left side, they lead to organizational performance. Things like commercial, not commercial performance in organization. It also leads to well-being. The opposite of the nightmares for developers, that thing. And what it is? Well, it's a change lead time. What does it mean? It means how much time it takes you from you start developing a feature till you have it in production. It is about deployment frequency, how often you deploy things. I worked on projects where we'd had 4 quarterly, 4 deployments in a year. That train has left the station. You have to wait for another 3 months or something, and then the next train will come. And that is not a thing anymore, right? We need to fix that. So deployment frequency is a good thing. You need to deploy often. And by deploying often, it's not just, you see the results really fast, but you actually know when the build breaks something, you actually know which commits actually were part of that. And it's much easier to iterate through 3 issues than 300. It's also change fail rate, because it's important to measure your things that fail often and measure it compared to whatever goes right. Because if you just measure number of failures and you deploy often, you will, the logical solution would be to deploy less often because, well, then we have less errors, right? So it's actually failure rate is a thing. And the other thing is that also when things go bad, it has to be quick to go to restore to normal production environment and stuff like that. So this is like time to restore services is also important. So those 4 things, you need to do a bunch of small things that lead you to those 4 things. And when you get that, you'll get really nice things at the end, like happiness in company, happiness as a developer, and all this stuff. You don't have to do all those things at the same time. You don't have to do all the things to tick off each of the boxes either. The little thing you do, the Boy Scouts rule, the little changes you make will make things a little bit better, and you can continuously improve on things as well. When you do that, do not take any of the metrics on religious basis. It's like the moment the measure becomes a target, it's gone. If you measure people by coverage, they're going to write horrible, horrible, disgusting tests, but they will have 100% coverage. When you measure by number of deployments, they will deploy for every letter. And, useless? Well, we humans are very good at optimizing on things that were being measured, except for estimation where developers are not. But that's a different story. I'm going to go through stuff, and at some point I will be stopped because I don't have enough time to go through things, but I can talk through some things, and we can talk about things afterwards as well. I can also tell you a lot of fun war stories about the things that I mentioned here as well. First thing I usually look at is the code quality. Show me the code. What do I mean by that? Well, I ask, do you have a code standard? Do you use that code standard? The answer would be yes, we have a code standard, but then you ask them, do you actually follow that? And then people tend to get nervous. I don't know, that's weird. Another thing that's encoding, right? It's not going to break your systems anymore, but it used to break a lot, and it can break, and it also tells me that your system is not using the same, like all developers are using kind of unified kinds of tools. So try to encode this, or that, or this. I actually Googled for the Norwegian words that contains a, and in one word, and that's actually only 3 words that exist, just in case you wondered. And that's another not Norwegian word, but yeah, still different encoding. It's not just ASCII kind of thing. Code quality, MIME types, very not important thing, still tells me that there is something fishy. I need to dig a bit more. Code reviews, do you do code reviews? Well, people say, the funniest explanation I've heard was, well, we don't because we know each other so well, so we just finish each other's sentences so we don't have to. That helps you to fix the deployment, fail rates and stuff, right? Finishing each other's sentences. Development tools, things like code versioning. I'm not going to tell you how to do that, but think about it. And I like things like branching and stuff. It's very important to think about that. Feature branches. How do you manage several versions out? Some in production, some in upcoming. You need to deploy a fix. All those things you need to think about. And there is a lot nightmare material behind that thing if you don't. Complexity testing. Static code analysis tools, all these kind of things. Use plugins that will help you with this kind of stuff. This is an important thing. Yes, I have 1 minute left, and this is good because I can talk about this stuff, and I have more stuff as well. But third-party libraries. How many of you have a control over all your third-party libraries? One hand? Okay, 1. Good. Very good. That's probably banks or something like that, right? Yeah, nodding head. Yeah, okay, sure. Do you have a control over your known issues and vulnerabilities in the third parties? Because it's software written by developers like me and you. We write bugs and software and security issues and stuff. We do create those. If you don't want it or do want it, doesn't matter. Do you have control over your licenses? And I don't mean like paid, not paid. Do you know that your stuff can actually get fully, GPL license just because you're using some kind of software that, or part of your software that is using that. And there is a lot of things that we can talk about. But now, by this time, probably we should finish off. And there is like architecture, and there's environments. There's a lot I would love to talk about that. We can do that afterwards. But time is up. Estimation and all this, right? Feel free to ping me and we can talk more about those things. And if you need some examples and if you need some ways of convincing your managers that's a good idea, we can always talk about that as well. Thank you all.